Hello everyone, Michael here. Signal flow. Okay. Now, this is a workspace where engineers, say electrical engineers, can design and simulate systems block by block. Control loops, analog circuits, DSP chains, comms links, all of them. Now, on the left, you have the component library. Here you have the sources, the math, the controllers, the plants, scopes, plus analog parts, digital logic, DSP, and telecom blocks. You see, everything you'd wire up on the bench right here. Now, up top, we have the controls here. I hope you can follow my cursor. Up top, we have the controls. We have the simulation time, the time step, save and load your project, export to MATLAB or JSON. You can run Monte Carlo simulations, okay, just to see how the design behaves under variation. Now, we've already opened a starter template, which is a classic feedback control loop, but you can check templates here. We have 5 of them. So this is what we are analyzing, the control loop. Now, here we have a step input feeding a summing junction, okay? The error flows into a PID controller with KEP 2.4, KI 0.6. How do you check this? You just click on this, come to tools here, and then you'll be able to see the parameters. Or you can also just zoom in and you'll be able to see the parameters. Now we have the error that flows into a PID controller with KEP 2.4, KI 0.6, KD 0.1 that drives the plant is a second order transfer function. 1 over s squared plus 2s plus 1, you can see it here, the plant function. Okay, the output goes to a scope and a unit gain feedback path closes the loop, just like that. Okay, now, like I said, every block is editable. Just click on your left, change a parameter, rerun. Okay, now here we have 8 seconds of simulation time and 10 millisecond steps. Now we're going to hit simulate. Okay, simulation done. Now there's the closed loop response. Okay, there's a quick rise, a small overshoot, and the system settles cleanly on the reference. Now the results panel gives you the actual numbers: rise time, overshoot, setting time, steady state error. These are the same exact figures that you'd compute by hand, but they are just live as you tune on our web page. On our web page. Uh, okay, just let me say, push the proportional gain and you trade overshoot for speed. Now, that feedback loop is the whole point. Design, simulate, see the results in a second. Now, when your design is locked, you can just export the whole system. Go to MATLAB or JSON and do whatever you want with it and hand it straight to the next stage, and you're done. So this is a tool that we've developed to help you design systems the way you think about them, block by block. Visit engineeringhub.engineer, design materials page, interact with it. Yeah, thank you.